You know, we're surrounded by AI that can see, it can describe our photos, analyze videos, and really help us make sense of the visual world. But there's this huge nagging problem. Sometimes these AI models, well, they lie. They see things that just aren't there. They hallucinate. So today, we're going to break down why this happens and explore a brilliant new fix that might just teach AI to see the truth, right? Let's dive right into that. It's such a fascinating question. We've got these incredibly powerful models, but they can be so confidently wrong. And look, it's not like the AI is being malicious or trying to trick you. It's a much deeper flaw in how they actually learn. Let me show you a perfect example. So, researchers showed an AI this picture from the movie Interstellar and just asked what was going on. The AI got the character right, the room, but then it added, "A cat is resting on the sofa behind her." Go ahead, take a second. Look for the cat. Spoilers, there is no cat. This is a classic AI hallucination. It sounds totally plausible, but it is completely made up. And that one example really gets to the heart of the problem we're talking about today, AI hallucination. It's a massive, massive hurdle if we're ever going to build AI systems that we can actually trust with important stuff. So just to be super clear on our terms, when we say AI hallucination, we mean any output that seems convincing on the surface, but is just factually wrong or, and this is the key part, isn't based on the actual visual information it was given. The AI isn't just misidentifying something, it's literally just making stuff up out of thin air. Now, obviously, researchers have been trying to fix this for a while. One of the most popular methods out there is something called direct preference optimization, or DPO for short. But, and this is a big but, it has a major flaw. You can think of it as teaching the AI to be like a student who just crams for an exam. Think of it this way. You've got the crammer on the left, you know the type. They aren't trying to understand the subject. They're just memorizing keywords and phrases they think will be on the test. They learn what a good answer is supposed to sound like, textually, without really getting the why behind it. Well, this popular fix, DPO, it basically trains the AI to be that crammer. So, how do you train an AI to be a crammer? With DPO, it's actually pretty simple. You show the AI an image, and you give it two descriptions, one that's correct, the winner, and one that's wrong. Then you just tell the AI, hey, this one is better. You do that thousands and thousands of times, and eventually the AI starts to get a feel for the style of a good answer. But the real question is, what is it actually learning? And this quote from the researchers, it just hits the nail on the head. DPO causes the model to overfit to shallow textual cues. In plain English, that means it's not learning to see what's in the image, it's just learning that certain words or sentence structures show up a lot in good answers, so it spits them back out, whether they fit the picture or not. It's learning to be a good test taker, not a good observer. And boom, here's the visual proof. You can't argue with this. These are attention maps. They show us what the AI is looking at. Now look at the DPO-trained model on the left, our crammer. See how its attention is scattered all over the place? Those red boxes show it's getting distracted by things that don't matter. It isn't truly seeing. Now compare that to the image on the right. We'll get to how we achieve that in a moment. But just look, it's laser-focused only on what's important. So if DPO is the student who just crams for the test, we need a better teacher, right? And that brings us to the hero of our story, a new, much smarter method called TARS. And it's designed to force the AI to actually think about the image, not just memorize word patterns. TARS is a pretty cool acronym, but what it does is even cooler. It basically plays a game with the AI to make it smarter. It constantly tests the AI by messing with the questions it's being asked. By changing the wording in really tricky ways, it breaks the AI's bad habit of just relying on text patterns and forces it over and over again to go back to the only source of truth, the visual evidence in the picture itself. So how does it actually pull this off? Well, the secret sauce is this wonderfully clever trick called token perturbation. Okay, so here's the magic trick. TARS looks at a question like, what is the person in the red shirt doing? And it's smart. It knows that words like person and red shirt are super important. They're tied directly to the picture. But the other words, what, is, the, doing, they're just sort of grammatical glue. So TARS focuses on those weaker words and tweaks them. It's a test. If the AI can still answer correctly even when the question is a little scrambled, it proves it's really relying on the picture, not just on recognizing a familiar sentence structure.
The researchers have a great name for these words: visual agnostic tokens. Just think of them as the words that don't really need the image to make sense, like articles, prepositions, basic verbs. By changing only these words, TRAS can check if the AI is truly grounding its answer in the visual details, or if it's just coasting on linguistic patterns. It's like asking a student, instead of "where is the cat?" tell me, "how is the cat?" If the student was just pattern matching the word cat, they're suddenly forced to stop and actually think.
So all this sounds great in theory, but does this clever strategy actually work in the real world? Oh yeah. Let's get to the results because they are seriously impressive. This right here is the headline number, 50%. On a key industry benchmark, cars cut the hallucination rate in half. That's a drop from over 26% all the way down to just 13%. That's not a small tweak. That is a massive leap forward in reliability. And this chart just makes that improvement so incredibly clear. The base model, on the left, with no special training, has a really high hallucination rate. Standard DPO in the middle, it helps a bit. It brings the rate down to about 26%, which is better, but still pretty bad. And then, look at TARS on the right. It just crushes it, slashing that hallucination rate all the way down to 13%. That's the power of forcing the AI to actually look at the picture. But you know, numbers are one thing. Let's look at a real-world example from the study, because this is where you really see the difference. The AIs were shown this image of a train, and were simply asked to describe it. Okay, check out these answers. The DPO-trained model on the left, our grammar, looks at this clearly yellow train and says, the image features a blue and green train. I mean, where did it even get that? It's a complete fabrication. But the TARS model on the right, it absolutely nails it. A yellow and red train. That is the practical difference between an AI that's just guessing and an AI that actually sees. So let's zoom out and wrap this up by talking about the bigger picture and why this research is so incredibly important for the entire future of AI. So what makes TARS a real breakthrough? Let's just recap. First, it obviously dramatically cuts down on hallucinations. Second, and this is huge, it's incredibly efficient. It achieved these amazing results with a tiny dataset of less than 5,000 examples and no expensive human labeling. Third, and this is the most important part, it fundamentally changes how the AI learns, forcing it to ground its answers in visual reality. And finally, the results are so good that this open-source method can now match or even beat the giant proprietary models like GPT-4o on these key metrics. And that really leaves us with this final provocative thought. This isn't just about fixing a technical glitch. It's about honesty. If we can teach an AI to be more truthful about what it sees, to ground its reasoning in actual evidence, what does that mean for the future? This feels like a huge step toward building AI that isn't just powerful, but is genuinely trustworthy.